School. The final frontier. These are the voyages of the starship Chemistry. Its 1-week mission to explore the new properties of aluminum, to seek out good grades and high academics, to boldly go where no student has ever gone before. Hello, chemistry class. This project is Amazing Aluminum. For the next part of the project, I'm going to be taking this iron nail and a piece of aluminum and put it in this water right here. So first we'll put it in. And then we let it sit for a week and see what happens. So we'll be back in a week to see what happens with this. The next part of the project, we're going to take this 10 centimeter by 10 centimeter piece of aluminum foil, put it on this frying pan, put 1 tablespoon of butter on it, let it heat up and see how it reacts to the heat. So let's get started. The next part of the project, I'm going to take this off, let it sit for a minute, then touch it with my bare hands after a minute and see how hot it is. Slide off like. Oh, this cord is dangerous. Alright, so now I'm going to touch it and see how hot it is. That's what it goes. It is very cool. So wow, that cooled off very quickly. Alright, so for the next part of the project, I'll be taking this wrinkled piece of aluminum and this hammer, and I will hit one side of the piece of aluminum, and after I'm done hammering, I'll see which side is easier to tear, the hammered part or the wrinkled part. Here we go. Hold on. Good. side's easier to tear. Really hard to tear. The hammered part is very hard to tear, and the wrinkled part is very easy to tear. So there we go. After a week, you can see there's definitely a big change. The nail, very rusted and corroded, definitely took a lot of damage, and obviously the water is very dirty. But the aluminum, still obviously just a little dirty from the corrosive dust that got in the water, but I mean pretty much unharmed and looks completely fine. So that was after just a week. It's pretty crazy. So the reason the hammered aluminum was harder to tear than the just the wrinkled aluminum was because when you hammer the aluminum, it compacted it and made it more dense, so it was harder to tear instead of just the wrinkled aluminum that was just not as dense as the hammered aluminum. So what makes aluminum a desirable material for pots and pans and for aluminum foil? Well, the reason is because it doesn't corrode at all, as you can see from doing the experiment with the nail. And also, it heats up very quickly and stays hot as long as there's a source on it. Once you turn off the heat, it cools down easily. So that makes it very desirable for cooking and using it in pots and pans. Well, that was Project Amazing Aluminum. This is Ryan and Braden signing off. See you later.